and Purdue Extension and MSU Extension on irrigation issues. Wish I could be with you there at the field day. I think it's hard on all of us being at home and not having the camaraderie. And I've always enjoyed that trip from St. Joe County, Michigan, down to LaPorte County, Michigan, the two most irrigated counties in both states. It's a good time of the year to be traveling and looking to see what was going on. Both from a chemigation standpoint or any other irrigation issue, you're welcome to email me or use my cell phone and call me. And we're going to refer to reference materials and additional information and longer presentations that are all going to be posted at the Purdue Ag Engineering site and the MSU Ag Engineering site and MSU Extension. So today we're talking about chemigation, that process of putting a pesticide, in this case fungicides because of the tar spot issues where most people are interested, but also insecticides or even nitrogen fertilizer earlier in the season through your irrigation system. It is important to remember that EPA, Environmental Protection Agency, requires that any pesticide that's put through an irrigation system have a chemigation label. That could be a separate label or it could be a subsection of the full label. And remember that the chemigation label is that three-way agreement, that legal agreement between the Environmental Protection Agency, the company that produced the pesticide, the registrant, and you, the applicator. And following the instructions there within that label, make sure that we have a safe and effective use of the pesticide. Today we're looking at the headline AMP fungicide label and the Trivia Pro label as references for some of the discussion. So one of the first things we come up to as far as whether you're going to put pesticides through your pivot is, can you actually get the application done in a fashion that meets the requirements of the label and is going to be effective? For a fungicide, like for tar spot or some of the other blights where we're looking at foliar diseases, we want to keep the concentration fairly high on the leaves. So we want the application to be really small, much smaller than we would for a normal irrigation application. If you look at the headline AMP label, they have a growth promoting effect that they like to see applied. To get that effect, they like to see it applied up to 1/2 inch of water. But when we look at a fungicide effect where you're trying to keep disease from advancing on the leaf, we want to say as concentrated as possible. The Trivia Pro label, they want to see anywhere between 1/10 of an inch and 1/4 of an inch, but not more than 1/4 of an inch. So the question is, can we get our machines to do that application that small? And then it's also important to remember that this is not, because the fungicide needs to be on the leaves, drip, trickle, subsurface drip, and flood irrigation are all not going to work for this, this application. So can our machine move fast enough to do this application? And a quick way of looking at that is just to look at the control labels or the control application charts. So the one at the upper right here, if you take a look at that, at 100%, that machine can go 1700. So it's right in the middle of the application area that we'd like to see on the Trivia Pro label. But the older machine down in the middle, its application chart, the fastest it can go at 100% will put on about 3/10 of an inch of water, 2.9 of an inch of water. Remember, if we were building machines, some of the newer machines were putting a separate set of nozzles on to do these applications. They target 7/100 of an inch. So it's all that concept that we can hold somewhere a little less than 1/10 of an inch in the foliage of our crop. Any product that leaves the leaves then is ineffective. So this getting it a uniform application but small enough is part of the issue. There's also an issue here as far as keeping the pesticides in the field. The Trivia Pro talks about making sure that the wind direction isn't where it's going to blow the treated water off of the field. More common in our areas is to have end guns that water beyond the field edge. remember, that's a violation of both Michigan and Indiana pesticide regulations. The pesticide has to stay in the field. And we'll talk a little bit more about that. The next thing we need to talk about is, okay, if we get it, a small enough application, is it uniform? And if you look at that headline AMP label, it says crop injury, lack of effectiveness, or illegal pesticide residue can result from an ununiform application. So what do we mean by uniform? Well, we're going to talk a little bit about how do we judge uniformity in machines. The Trivia Pro label goes as far as to say that they cannot use this product in machines that have the end guns on. So do not use the end gun. And when you start looking at that, some of us are going to choose our pesticide by the label and when it's allowed to be used. If you look at the lower right-hand side of this picture, if we eliminated those orange blocks where this pivot end gun would be turned off, we'd have a fairly large portion of the field that was untreated. And from that point on, there's a good share of this field that is not irrigated. So we're only going to get the fungicide application where the pivot is actually running. So we're going to choose our application method. Maybe we'd be better to do an aerial application in this field. Or if I may want to choose a pesticide that I can use the end gun for. When we talk about uniformity, probably the greatest culprit in uniformity is repairs that need to be done. Some of the most common ones we see that have major fluctuations in the application would be the piping systems having major leaks. So you got on the upper left there, stem to a pivot that's leaking. If you think about the amount of pesticide that's going to be in that one area, it would be huge. Flange gasket on the upper right is missing. These are all general repairs that ought to be done, but we have a tendency to let those go. But this is, if we're going to put a pesticide through those machines, we don't want to have heavy concentrations there. In the middle, we've got the fountain of youth, the 3/4 inch hole that's supposed to have a sprinkler in it, but it's missing. There's a huge application under there. We already talked about the off-road applications. That's a matter of getting our controls aligned up and working so that we're not watering the road. And then the last one takes a little longer to understand, but if you're used to cornering arms, and we're in the area of the world that has the greatest number of cornering arms being used, those cornering arms have a controller on them that sequences those valves. And when the arm is folded back, like this one is, it should be shutting off those valves in the end gun. Here in this situation, that same area on that edge of that field is getting every sprinkler plus the end gun. These are all major issues before we would ever consider putting a fungicide through the pivot. Once we have the repairs done, we need to be thinking about uniformity. Both the soil conservation districts in northern Indiana that are in heavily irrigated counties, and in Michigan, the Michigan Agricultural Assurance Program, have technicians that have done these over the years. Basically, the concept is to put a test cup every 10 feet from the pivot point out to the furthest reach of the machine. In a perfect world, every cup would have the same amount of water in it. When we look at the graph here, each of the dots, blue dots is a cup, and if you notice at 220 feet, we aren't getting anything, so there's no application there. And like many of our machines, the biggest issue is out there at the end gun in the final application area. These are all things that would need to be corrected, otherwise we get under and over applications before we actually do the pesticide treatment. Some of you are going to say, well, I haven't done that uniformity testing. What do you think the minimum is? Well, ideally we would have the uniformity testing, and we would have a Christensen's coefficient of uniformity that meant that of 85% or higher. That means that the bulk of the field is getting between 85 hundredths of an inch and 1.15 inches if we had that 15% deviation or an 85% uniformity. So that's where we'd have if we had the testing. If you don't have the testing, think about it that all of the major repairs are done, the sprinkler package matches the chart that's in the machine, and that your pressure is within 10% of the sprinkler package specifications. If you're outside of that, we're pretty sure that you're not going to be close to being uniform enough. So if I have a pivot that's supposed to have 30 pounds and it does not have pressure regulators, but it's supposed to have 30 pounds at the pivot point, it should be between 27 and 33 pounds. We're going to talk about backflow requirements in a second. We already talked about major leaks are there. We don't want systems that have runoff issues. In other words, we don't want the treated water to be leaving the field in runoff forms. We'd like to have minimum numbers of areas that get 2X applications, in other words, covered by 2 different pivots. So we'd like to make sure end guns and things are shut off so that those areas are minimal. And then we're going to talk about interlocking systems for safety. So that big safety component here is a backflow valve. Remember, the water that you drink when you're on the farm, probably the family's water or the employees that are living near that area, they're all drinking that water supply, plus the general public that we deal with in that area. We're all using the water supply, whether it's rivers, lakes, streams, or wells. We need to protect that. So what we use is a backflow valve, but it's a special backflow valve called a chemigation valve. Notice the backflow valve at the bottom is basically just a flopper valve with a 5-pound spring on it. When the water's on, it opens up the spring. As soon as the pump goes off, the flopper valve fluts shut. The difference is the chemigation valve has an air relief system that drains all of the water that has not had the chemical injected in it and allows it to go back down to its source. So the way that it works is a floating ball at the top. That silver component up there has a little floating ball. When the water comes on, the floating ball closes the opening. There's an inspection port that allows you to do an inspection to make sure that the seal is good. And then we want to drain that cavity between it. And if there's any minor leaks coming from that flopper valve, we want them to drain on the ground, not back down the well or back to the river. So we have a 5-pound dump valve on the bottom below the floating ball valve. These are all components to break that vacuum and help protect our water resources. There's one more valve in there. There's a valve that is actually the emitter for our fungicide or our nitrogen, depending on what product we're using. It goes into the injection port, and what it does is performs 2 things for it. It mixes the water with the pesticide, and it prevents irrigation water from entering and flowing back towards the injection pump or the injection tank. So those are very important components that are there. A few of us may be using water from public water supplies, or we may be sharing a water supply with a home or homes. It's really important to remember that when we're sharing with a human water supply or a public water supply, that we use a different valve. It's called a reduced pressure zone valve. It is a much more complicated valve, and it's designed to have continuous pressure on the feed side. So it's really made to hook up to like a municipal water line. But we'll see in some situations some temporary irrigation coming in off of a fire hydrant, or maybe a project where we've got a temporary garden or something. The options in there are the reduced pressure zone valve that needs to be installed by a certified well driller. And usually an annual inspection is required. Those rules are all in your what is known as well code in both states. The only alternative for those situations is to have an air gap between the water supply and a holding pond or a makeup tank, and then irrigate from those. So those are options too. So we need to think a little bit about interlocking. Interlocking is the concept that if one component of the chemigation system and the irrigation systems and the pumps goes down, that all of them go down. What this does is prevents us from missing an area in the field if the injection pump stops, having way too concentrated of an area covered in the field if the pivot stops moving, or filling your pipe full of concentrated solution if the water pump stops moving. So most of this is commonly already in center pivots. It's a little harder to do with traveler irrigation, but it's still achievable. These are the systems that turn off the pump if the pivot stops moving, and they're commonly already installed. all we need to do in most situations is install the linkage between the injection pump and the panel so that it all shuts down at one time. So the goal is that if one component shuts down, all of them shut down. There's a little bit of a challenge or change here in the last few years. More and more of the chemigation labels are requiring a normally closed solenoid valve between the injection pump and the chemigation tank, the supply tank, or the fertilizer tank, depending on what you're dealing with. This is not a terribly complicated thing. Basically, we're wiring in this solenoid valve that is normally closed, so it only opens when the injection pump has electricity going to it. Its purpose is to keep the pressure from the supply tank from flowing through the injection pump or onto the ground if the system is turned off. The other thing to mention at this time is that most of the chemigation labels are going to have an agitation requirement. So most of our chemigation specific pumps and tanks have those already on it. See the agitation motor there at the top. And then if you're using a fertilizer tank, there are retrofit systems that are available. It's a good idea to make sure that you're keeping your solutions uniform so that we don't have a higher concentration as we get to the bottom of the tank. So some of you are going to say, well, I'm not sure, I've got too much of my field is not going to get covered by the irrigation system. I'm really not going to worry about chemigation as far as dealing with these fungicides. And you're probably more interested in finding out how can I manage my irrigation to minimize the potential of foliar diseases in my crop. And here's some charts that we've recently done by Dr. Young-Suk Dong from MSU Biosystem Ag Engineering. The lower chart is a sensor about 2 foot up, between 2 and 3 foot up, a third of the way up on the crop. And the upper chart is 2/3 of the way up. If you take a look at a disease like tar spot, they believe that we need 7 hours of wetted time for the disease to advance. So if you look at this upper chart, we had 8 situations that were over 7 hours of wetted time. Some of those were caused by rainfall. And you can see on the orange lines, the rainfalls have multiple readings at where the irrigation, the water all came within an hour. So it's like one big number. The first 2 green arrows are both irrigations, about 1/2 inch in size, and their duration of wetting time was only less than 2 hours. But the third arrow, that irrigation was done in the late evening, and yet crop stayed wet for 8 hours until it dried off the next morning. So there's some advantages out there to when you're applying water. Most of us that irrigate, when we're near peak use, we don't have the capacity to only irrigate from, say, 8 in the morning till 6 in the afternoon, when the water would commonly dry before we got into the dew, the wet portions of the day. So really, this is only an advantage if you have a lot of water supply compared to your field, or if you can time it so the areas you're most interested in protecting are being watered during the middle of the afternoon when we're going to have some drying. The other thing that we can look at that all of us can do is what size of application are we doing. If you look at a typical August, we need about 6 inches of irrigation water. We know that from an evapotranspiration and some of the scheduling work that's being done. Both Michigan State University and Purdue Extension have extensive work in estimating how much crop water is needed to grow a crop. You look at the websites for that information. But if we said in the typical August, I need 6.3 inches, and about half of that we're going to get in rainfall, we're going to need about 3 inches of applications from the irrigation. If I did that as 3 1-inch applications, I'm going to have 3 wetting events that happen. If I go to the other extreme and do 12 1/4-inch applications, I'm still applying 3 inches of water, but I'm going to have 12 wetting opportunities for the disease to advance. So there's a real advantage to staying to larger applications. The other advantage to staying to these larger applications is you get more water to the crop, because as we said earlier, about that first 8/10 to a 1/10 of an inch, first 8/100 to a 1/10 of an inch of water stays on the surface of the plant or on the surface of the soil and never really makes it to the root system. So when we do large applications, we have fewer of those losses to evaporation from leaves, and we end up with more water to the plant. In this case, those three 1-inch applications get 2.7 inches down to the root system of the plant, but our 12 1/4-inch applications only get 1.8. So there's a big advantage to larger applications. Not all of us can do those larger applications. Some of us have equipment that applies water faster than it can go in the ground, and we need to do small applications to take advantage of the surface holding capacity of the soil that's there. There's discussions on selecting nozzles at those websites that can help you try to avoid runoff issues. So that's what I got today. I hope that we have a good season as we finish up. If you have any irrigation questions, I'd be glad to take your call or send me an email and I can respond. Address and phone numbers are there, email address, and the websites that we talked about with additional information. So I think, Phil, that takes it back to you.
Yeah, so if you have any questions for Lyndon, just type them in the chat there, and so we don't have people unmuting and having a confusion there. Type them there, and I'll get them to him, and he'll answer them now. Here's one question for you, Lyndon. So with, say I've already got the center pivot that can take the fungicide, how much will it cost to set it up with the backflow preventer and everything, and will that be worth it compared to hiring out either a high boy or airplane to doing spraying? Good
question. So we've done some work with NRCS in both states over the last few years, and they estimate that most machines that are up to date and capable, we could add the backflow preventers and the interlock systems for about $3,000. So that's a lot of times what the cost share is on there. If we think of a 160-acre field, 142 of that is commonly irrigated, unless we have cornering arms. If I was to hire an aerial applicator to do that application, it would be about $12 an acre. So that comes out to just shy of $1,700. So really, 2 applications I would pay for my equipment. When I look at producers that are out there, they either want to deal with this or they don't want to deal with this. The producers that gear up and want to do this usually have a trailer with the equipment mounted on it. And when I ask them, a lot of times they'll say, oh, we do about, this serves like 12 pivots, and we do 1 or 2 applications a year with it. So those people, it's drastically cheaper that's there. They all point out real quick that it really depends on whether you have other areas in the field that aren't going to get covered by the irrigation system, because it's really hard to get your applicator to come in and do just the corners. So that ends up being a limiting factor. Any more on that or any other questions?
Here's another one. So I know with regular pesticide applications through sprayers, we got to clean out our booms. What's the process for cleaning out our irrigation line with the fungicides?
Most of the labels have a flush period that's required. Actually, I heard that question yesterday, and we were talking about it. And the important thing is not to wash your pesticide off that you want to keep in the leaves as you're flushing. Most of us, if the pivot goes all the way around, that's not a problem. We just turn off the injection pumps and let the unit continue to run, and it's going to be covering the area that was done first, usually 12 to 24 hours ago. If not, you probably want to wait 6 hours or whatever the rain fast period is for the pesticide you're using. Always read and follow the label that's there. But most of us are going to need to flush somewhere in the neighborhood of 10 minutes. Usually we think about double the fill time for the pipe. Most of our 6 5/8 inch pipe machines are fill in 6 to 10 minutes, depending on pump size. So we're looking at flush times somewhere in that 12 to 20 minutes.
All right, any other questions, you can type them in the chat for Lyndon. Doesn't have to be specifically on this topic, or just, you can ask any type of irrigation questions and Lyndon can answer that for you. And if you don't, Lyndon put up his email stuff, and I'll send out the contact info for our speakers today. So if you want to email or call them later to talk more about some subjects, I'm sure they'll be more than willing to talk to you and get your question answered on any topic.
Thanks, Phil. I enjoy talking to producers. It's the best part of my job. This being home alone is hard on all of us. My wife tells me I need to talk to more other people so that I'm not trying to talk to her all the time. So if you're thinking about putting in irrigation for the first time, or you're dealing with an issue that's irrigation related, please give me a call or send me an email and we can work through that issue.
All right, so our next speaker is Darcy Talenko. She's our crops disease specialist. So on this, Darcy and I went out to actually a field in Pinney, Purdue, and we did a video. So first we're gonna watch this video and Darcy's gonna talk about some diseases. And so we'll get to see some close-up stuff there, and then we'll be available for questions. So type those questions in the chat, and we'll see if we get this started.
Hi, I'm Darcy Talenko, Extension Field Crop Pathologist at Purdue University. And today we're here at Pinney Purdue Ag Center to look at our field plots and talk about field crop diseases. So one of the biggest questions we're getting this season is about the foliar diseases in corn, especially southern rusting corn and tar spot. So here I'm standing in front of our research trials up at the Purdue Pinney Ag Center, where we're trying to evaluate different programs for managing tar spot. As for this field, the disease is just beginning to start. And many of our fields that have had a history of tar spot, particularly in 2018, those are some of the fields we're monitoring this year as the disease is starting to begin and click up through the canopy. So when you first start looking for tar spot, it's important to understand your field history. Did that field have a disease problem in it, either with tar spot, gray leaf spot, northern corn leaf blight? All of those diseases are going to overwinter in the debris. So when we're scouting for those diseases, it's pertinent to start looking in the lower canopy at those lower leaves. Is the disease there? Is it active? And some of those indications can tell you whether a well-timed fungicide would be necessary. Here in our plots, the crop is about R1. We're beginning to find a few lesions of tar spot. When you're looking at it on a leaf, and I'm just going to pick a leaf for this example, you look closely on it. And if you think you have tar spot, the first thing we're suggesting our growers to do is scratch at it, because many times these early leaf symptoms may be mimicked by insect frass. And if it is insect frass, if you scratch at it, it's going to come off. Versus if it is a tar spot stroma, that stroma is growing embedded in that leaf tissue and it won't scratch off. Here's an example, again, of a stroma of tar spot that we're finding here in our research site. As you can see, it's almost a needle in the haystack. We found one little stroma on hundreds of leaves we've looked at. But if you look at it, it's embedded in that tissue. It's almost raised, coming up a little bit if you look real closely with it, if you have a hand lens. So this disease is starting to slowly appear, depending on your field site. This is 2 leaves down from the ear leaf. So again, it is slowly moving up in the crop canopy. Again, if you always have questions on tar spot, you can send us a picture or a sample to the Purdue Disease Diagnostic Lab. But as we continue to scout for tar spot, the disease will eventually move up the canopy. We are starting to find some fields where we see a few lesions on the ear leaf and above. And the idea when we're trying to time a fungicide is we want to manage and protect that ear leaf and above to try to get the best yield out of the crop. Tar spot of corn has been one of those diseases we've been tracking here in Indiana since we had a big epidemic in 2018. We're standing here in front of our research plots where we're trying to evaluate fungicide efficacy and fungicide timing for managing tar spot. We have begun to see tar spot in northern Indiana. We are tracking it where it's active. Last year we confirmed 68 counties that we were able to find tar spot. Of those, the counties that I'm most worried about are those in northern Indiana where we have the environmental conditions that may be conducive for this disease. The tar spot really likes high moisture conditions, generally lower temperature. So around the lake effect, around Lake Michigan is where we're seeing the highest incidence of tar spot, and that's where we've seen the greatest yield impacts. We track the activity of tar spot using a IPM map as shown here. You can see that we have a number of counties that are colored yellow, which indicates that we have found active tar spot lesions within the crop canopy. Also, the areas also show that we have 68 counties. We did confirm tar spot, so that means there is potential for that pathogen to be present.
To determine the risk of a field to a disease, it's important to understand the disease triangle. There are three main factors that contribute to plant disease: the host, pathogen, and environment. First is a susceptible host planted in a field. That may be the specific plant species, corn, soybean, or wheat, or also whether a variety or hybrid that you selected is susceptible to that particular disease. In addition, it may be important to understand what growth stages the various diseases may appear. The second thing to consider is a virulent pathogen present. Many of our pathogens we monitor in Indiana do overwinter in the crop debris, so it's important to understand if the field has had a previous history. These may include such things as gray leaf spot, northern corn leaf blight, tar spot, and frog eye. In addition, some of our diseases may move in with weather systems through spore movement, such as southern corn rust. This disease does not overwinter in Indiana, but each year we monitor its movement from the south. But once we know whether a pathogen is present and a host, the big factor that we need to consider is the environment. Is there a favorable environment that's going to promote the disease to develop within their crop canopy? Each disease has its own set of temperature, moisture, and leaf wetness requirements for that disease to occur. So it's really important to understand what those requirements are and if the environmental conditions are going to be conducive for that disease to develop. For example, if it's hot and dry, many of our foliar fungal diseases will not become a problem during the cropping season. But if the environment should change and we get a lot of leaf wetness and moisture, then there's a greater risk for those diseases to develop.
So when we know that we have tar spot present, then the question is, are the environmental conditions favorable for the disease to continue to develop within that crop canopy? So you can see here we have, I think, 11 counties now, but it may increase by the time this video comes out. But again, we're tracking this map to determine where we know tar spot is active. And this will just give you an idea of where those conditions have been conducive to start seeing the disease. Those farms in those counties really should get out and look around their crop to see if they can find it. If you have questions, you can always send me an email or give me a call. A second disease that we're monitoring in corn is southern corn rust. This disease does not overwinter in Indiana. Every year it blows up from the south. This year we knew that there were some southern epidemics that occurred early. There was a hurricane system that moved and blew some of those spores up in June, and we have begun to detect southern rust in many of our fields across the state. Again, we have a map that tracks this that'll tell you where we have found southern rust. So we have had samples sent in all the way from southern Indiana all the way up to St. Joseph County in northern Indiana. So we are tracking this disease. Again, it's something else to watch for. If it does get a hold, there may require a fungicide spray. When we're looking to try to control any of these diseases, we have to think about the best timing for putting out that fungicide. In general, for gray leaf spot, northern corn leaf blight, a VTR1 application has been very effective in helping minimize and reduce the yield impacts of those diseases. For tar spot, we're still trying to determine that best window. We encourage many of our growers to hold on to their sprays because we want that fungicide there for the 2 to 3 weeks when it's active, when the disease is going to be kicking up in the canopy. So many of our growers, I had them hold off until about this week, where many are starting to spray, where the disease is starting to kick up in northern Indiana. But we don't know beyond R3 if a fungicide application will be effective. So it's important to understand the growth stage of your crop, how active that disease is in the lower canopy. Is it really moving up? Will a fungicide then be effective in trying to manage that disease? So if you're trying to make a decision on whether you want to put a fungicide out in either soybeans or corn, it is important to understand your disease risk for that field and the diseases you're trying to target. In corn, it may be northern corn leaf blight, gray leaf spot are the two major ones here in Indiana that we might want to put a fungicide out to control. Tar spot is a new disease that we're also monitoring for that, in addition to southern rust.
This is a diagram of trying to understand fungicide timing. So again, we talk about being out there and scouting for the various diseases. In corn, we need to be looking at the late vegetative stages. Is gray leaf starting in those lower canopies? Do we find frog eye leaf spot in soybeans at the R1, R2 stage? Are those diseases starting to be active in the field, and are they going to trigger the need for a fungicide? So yes, we see that diseases are active in those crop canopies. We do decide to put a fungicide out, generally in corn, again, the VTR1, for soybeans R3. And that fungicide is providing residual protection from a 2 to 3 week window. The idea is we want to lay the fungicides out when we know the diseases are going to build up enough to impact yield. Maybe in another field, the weather conditions have been slightly different. We don't see diseases for a few weeks later. Therefore, a decision's made to put a fungicide out, but it's had a later application window. That field B may show residual protection later in the season, and sometimes that may show the difference between whether one field or another sees a buildup of disease at the end of the season. And finally, if diseases aren't active until the end of the season, corn has reached R5, soybeans R6, generally an addition of fungicide at this point is not going to give you that return on investment for putting it out there. So the idea is we really want to understand when are the diseases active, and we want to put those fungicides out when we know we can manage the disease and protect that yield. And we don't want to go too early because we may run out, the fungicides may run out of steam when we need later protection at the end of the season. So again, it's really important to be out scouting and looking for those diseases to make that well-timed fungicide application.
As for diseases that are occurring, gray leaf spot has been pretty active. So if you've had a field with a history of the disease, it's in continuous corn, gray leaf spot may be moving up to that ear leaf this year in Indiana. So here's an example of a leaf where we could have multiple diseases occurring. So a little bit of gray leaf spot starting, then we have a tar spot stroma occurring, and then also down in the leaf tip, there is some rust pustules. Now to confirm if I have southern rust, I'm going to have to take this back to the lab and look under the microscope to look at those spores to differentiate between southern rust and common rust. As for soybeans, they're relatively quiet. Across the state where we've been scouting, we found a few lesions here and there for frog eye, but nothing that really has triggered much of a need for a fungicide spray, unless you have a soybean variety that's out there that's highly susceptible to frog eye. And the other thing, looking at tar spot, as the disease progresses, it may be important to put a fungicide spray out if the corn is before R3. Okay. So we're out here in our soybean research trials here at Purdue Pinney Ag Center. We have a couple different projects going on. The first, we're trying to look at white mold management and how the best fungicides for that and timing. So we have some trials out looking at how to manage white mold. As a reminder for controlling sclerotinia white mold, this disease, the spores are released about the time of soybean flowering, and that's when the infection occurs. So it's highly important to understand the growth stage of the soybean to make that timely fungicide application. A few other things we got going on include looking at sudden death syndrome and how do we manage that disease. We have a bunch of different seed treatments we're evaluating on their effectiveness to try to protect the soybean roots from being infected by the fusarium and causing the disease to appear later in the season. In addition, we also run fungicide trials trying to rate efficacy of the different fungicides, especially if we get new products for frog eye leaf control. So there's a few different programs we have going on trying to best manage our soybean diseases. Luckily this year, many of our diseases are relatively low in soybeans. We have found a few frog eye leaf spot lesions around the state, but generally nothing that requires a fungicide spray. I am starting to see in areas where you have a history of sudden death syndrome, those symptoms are starting to appear in the field. So it is important to get out and look at your fields and try to identify if you have any of these problems appearing. Some of these soil-borne problems, again, you need to understand what's going on this year to make management decisions for the future. Our program will continue to track various diseases across the state. We have sentinel plots at all the packs in Indiana, trying to monitor the different diseases. This includes monitoring for southern rust, tar spot, and the various other soybean diseases. You can look at our maps and try to see what we see active, and we'll try to keep you posted on if any of these diseases should be of concern on your farm.
All right, hopefully that worked out okay. Haven't been able to see. Now for, if you have any questions for Darcy, you can put them in the chat. So here's a question for you, Darcy. With I know you're doing herbicide, or not, the fungicide trials for the tar spot. Do you have any early results on efficacy for that, or timing, or you're still waiting for data from this year?
So this year's data is just beginning to start collection. We do have 1 year of data under our belts from 2019. In general, from that data we collected, most of the fungicides we evaluated were effective in reducing tar spots. So there is a number of fungicides available. The one thing we did learn is timing is going to be important. And maybe, Phil, can I share my screen maybe? I can possibly pull something up if would be helpful.
Yeah.
Let me go see here. I'll pull something up real quick. So what we learned is looking at the disease epidemic from last year, we put out timings, most of our fungicide efficacy timings, and we're doing a multi-state coordinated effort. That VTR1 did work. It managed to keep tar spot low for about 3 to 4 weeks. But then at the end of the season, you could see where the disease is picking up. And so I was trying to see if I can share one of my slides here, if I can find it. Just give me a second. All right, I'll share my screen here real quick. All right. Okay, so can you see that screen?
Yes.
Okay, so this is just an example of one of our uniform fungicide trials from 2019. So you can see on the 13th of July is when we first found tar spot in Porter County. And this disease remained relatively low, and then all of a sudden, towards the end of the season, it tends to spike. So you can see here in the non-treated control, this gold line, disease was low. We were keeping, with the fungicide application made at the VTR1, we reduced the disease cycle. So you can see all the fungicides kept the disease even lower. But then as that 2 to 3 week window starts to run out, that's when you can start seeing that tar spot began to expand in those canopies that were treated. And so that's the one thing we're really questioning is, if we had gone out in R2, would have that helped protect a little longer in the season? And would we have seen the benefit of a little bit more yield benefit than what we saw from that VTR1 stage? So that's what we were trying to encourage many of our growers, just to hold on a second and see if later the R2 application works. For this season, we're evaluating all sorts of timing applications. So we did start at V10 and we have the VTR1, and our site at Pinney is a little behind, which is we're trying to catch that later disease. So hopefully by the end of the season, we'll be able to tease out if any of these later applications would be effective. We're going to go all the way up to the R5, and then some of our programs do have a double hit of trying to manage that disease. Let me see if I can share here. The thing with our fungicides after this year 1 here in Indiana, where we had that well-timed, that VT application, we did see overall many of our trials, we could get a 17 to 20 bushel yield protection. So again, where the disease got really significantly high in the field, these fungicides will help protect it and they will protect the yield. We just don't know if there's even more yield to protect beyond that. So that's some of the questions we're trying to get at. I am collaborating with Wisconsin, Michigan, Illinois, Iowa, and we're trying to look at some of the modeling and using some of these weather conditions. I know Lyndon talked a little bit about irrigation, but we do know that water is going to drive this disease. And it may even push it through, and you may have seen this slide before, but I just want to show this is an example of where they had multiple small irrigations, and even though this field had a fungicide applied, the disease took off. So water is a strong driver of the disease, and so that's just something we really need to monitor, and I think that's why in northern Indiana, that's where we see the greatest effect of tar spot and the annual effect that it's had occurring. I don't know if that answered it. Do you have any other questions, Phil? Questions, comments? We are trying to track activity through the state. So my team in another couple weeks, if we start seeing more tar spot activity, is going to try to get across the state to see how widespread it is. We didn't really get to the southeast side of Indiana, so we're going to try to start there. I suspect we could find 1 or 2 stroma across most cornfields during the season, but again, it's when it starts moving up in that crop canopy and we see that significant blighting, that's where we're going to start seeing the yield losses and the reduced yield potential for that disease.
So do you have any, we'll move on to soybeans, because I know you've been looking at resistance. Any updates to frog eye, leaf spot, to fungicides? Any updates on that?
Yeah, so when I arrived here at Purdue, we knew that there was some counties we had confirmed strobilurin resistance, the QOIs. I have a graduate student working on that, and I guess I could share my screen again. She recently got back in the lab, so we could, let me see if I can find it. Look at the strobilurin resistance. So last year we went around the state, collected samples, and of course frog eye last year was a little light, but we were able to collect samples in, I forget how, 9 counties, or I think 10 counties. And so she just recently finished up some of this work. And so we have continued to confirm that of the 10 counties, 9 we were found strobilurin resistance in that Cercospora sogena population. We were surprised to find that we do have 1 county that all the samples we sampled from that county did not have the resistant genes. So there still may be some populations out there that don't contain the QOI resistance yet. But again, we'll be searching and collecting frog eye this season to see if that holds true. This means that when we look at trying to manage frog eye in our soybeans, first, if you can identify a resistant variety, maybe rotating to a non-host like corn to try to reduce that inoculum within a field. But then when you're looking at your fungicide applications, it's going to be really important, and we suggest it anyways, to use a multi-modes of action. So using a fungicide with 2 modes of action, the strobulurins could be in there, but you need to make sure there's an additional group like a DMI or a thiophanate within those products in order to try to manage this, especially if we're dealing with fungicide-resistant populations. And I think that's about, and we continue to track southern rust and corn. So here's an updated map. So you can see Georgia and Alabama, Mississippi have been seeing a lot of it, and it blew up, but we got it all the way up to Wisconsin. Again, if you have questions, we're trying to map these diseases. So tar spot, southern rust, or any other disease of interest, please, if you have questions, send them. You can send them to the diagnostic lab. We do have Indiana corn marketing support for research that we're doing, and that includes free samples, submissions for corn diseases. So if you want to send us a sample, there's free of charge for farmers in Indiana. So again, we're trying to just monitor and track some of these diseases to develop some better ideas on how to manage them. With southern rust as well, generally, if you look at some of the data that the southern pathologists have done, fungicide applications up to R3 might be effective, but anything beyond that, they're not sure that they'll get the return on investment if the disease is just moving in at that point in time. So again, it's just important to understand the activity of the diseases and how it's moving up in the crop canopy. Phil, did you have any other questions? I don't see any.
Yeah, I don't think I haven't got any other ones. So
Okay.
Thanks, Darcy, for the presentation, and I'm sure we'll all send out your contact info if people want to reach out to you if they have other questions. So
Okay.
all right, so our next speaker, we'll have another video that we did with Christian Krupke. It's on corn rootworms. So I'll get that up here in a second.
I'm standing beside a conventional cornfield at Pinney, Purdue Research Farm. It's August the 7th. And the reason I'm standing here, what we're going to talk about today, is an old familiar pest that hasn't been much of an issue in the past few years, and that's the western corn rootworm. And this planting that I'm standing beside is part of a research trial that, among other things, is looking at how long it is before you have western corn rootworm showing up in unprotected conventional corn. And I'll get to more details about the answer to that in a moment, but what we found this year is that many producers have gone with conventional hybrids. And that's a departure from past years, and it's probably due to a combination of weak commodity prices and low pest pressures that we've had over the past few years. And so some producers are taking advantage of that opportunity to move away from the BT hybrids, away from those tech fees, to conventional hybrids. And one of the purposes of this session today is to remind everybody that that choice is fine, but western corn rootworm hasn't gone anywhere. And protecting yourself against that pest is still something you're going to have to consider if you're going with conventional corn. Now, nationwide, we're still probably at 85% or so of corn is a BT hybrid, BT corn. Many of those hybrids are stacked with above ground pest traits, so your corn earworms, corn borer, western bean cutworm in some cases, and your below ground pests, which are just the corn rootworm. So the vast majority of corn in the US is still planted that way. But we are seeing a move and an opening for conventional corn hybrids. If you plant untreated conventional corn, there's nothing preventing rootworms from feeding on that corn. And what we've seen is that you can get by doing that for a year or two or possibly even 3. But at some point, you're going to have enough damage and enough rootworm feeding that you're going to have corn that's lodged in the field. And that's what we've seen this year. With some of the heavier rains in the past 2 or 3 weeks, followed by some heavier winds, we've seen a lot of lodged corn. That's one indicator that rootworm feeding has been heavy. By the time you see that, it's too late to do anything. Nothing can be done to preserve that year's corn roots or to stand that corn up again or anything like that. The other indicator, and what we saw in this field a couple of weeks ago, is a lot of adult rootworms. And corn rootworms as larvae only feed on one thing in the Midwest, and that's corn roots. So if you have a lot of corn rootworms in a field, it's a good bet that they came out of that field that you're standing in, because they only move, like most insects, most animals, they only move as far as they have to get some nutrition. Now, as adults, they'll feed on a variety of things, not just corn, but they do feed on corn leaves, which is inconsequential, but we'll show that in a minute. They do feed on corn tassels, and they usually are synced up with pollination time. So in some cases, there's enough silk clipping that an adult spray will have to be applied. That's not usually the case in Indiana, hasn't been for a long time, but it's certainly not unheard of. In the past, if you go back 15, 20 years, you'll hear more cases of silk clipping to the extent that adult insecticide had to be applied. But today we're mostly focusing on the larval stage, what to do if you have lodged corn in the field, and how to assess steps for next year in terms of rootworm management if you need to do something differently. Now, as I mentioned, adult rootworm feeding will occur in corn and out of corn. The main thing that they're after is pollen. That's their main food source, especially for females that are developing eggs. But they'll also feed on the leaves. As you see here, we call this window painting. Here's a couple of rootworms just flew in and out of this shot here. And they will feed on leaves, but leaves aren't a great source of nutrition. But when you see this, these stripes are characteristic. They don't chew holes so much as just take all the green out, and we call this window painting feeding, and it's usually in strips when it's rootworm feeding. That's fairly diagnostic. Now, this level of feeding is nowhere close to economic. This plant has more than enough green leaves to do whatever it needs to in terms of photosynthesis for the rest of the year. All this does is tell you somebody's been here, rootworms have been here feeding. That's what this is an indication of. This kind of feeding is diagnostic of rootworm feeding, and as you can see, it's on a lower leaf, which is even less consequential. You can see as this leaf sits here, a lot of it is shaded out anyway by leaves that are up above. And so that means that the sunlight is hitting those leaves and there's photosynthesis happening. So there's rootworm feeding on leaves is nothing to be concerned about. Rootworm feeding on silks is when we worry. We're well past that stage now, of course, but that would be the only way that rootworm adults would be something that you would want to manage. Yeah. Male and female rootworms look very similar. The western corn rootworm, the males have black on most of their wing covers, or elytra. They don't have defined stripes, whereas the female has a central stripe and one black stripe on either side on a yellow background. Okay. Male and female rootworms will be around for most of the rest of the summer. Female rootworms will be laying eggs in cornfields until well after Labor Day, and sometimes until the first frost. And during that time, they'll also be feeding on pollen from a wide variety of weedy plants. If you happen to have squash or zucchini or melon flowers, any of that family of plants nearby, those are especially favored by adult rootworms that are looking for food. And in fact, sometimes can be used as a trap crop for them when we do our research trials. All right, if you suspect you have rootworm feeding, for example, if you have lodged corn, especially if it's conventional corn or unprotected corn, if you have lodged corn, a lot of beetles in the field, the most important thing to do is to dig some corn roots to look for the larval feeding. Now, as we stand here in early to mid-August, it's a little bit late because there's been some root regrowth, so you won't see the feeding as well. But if we did this about 3 weeks or a month ago, would be the perfect time. But what I'm going to do now is just demonstrate simply what you do. You just dig up a corn root, chop the stalk off, and I'll show you some of what to look for on the root itself. So I'm going to work on an edge plant here, but that is never what you should do. Plants on the edges are not representative for a number of reasons, but just for filming purposes, I'm going to work on the edge. But you would always want to walk in 10 feet or so and then do multiple areas of the field. And the more plants, the better. You would want to do in an area with a lot of lodging, 5 or 10 plants would be a minimum. Again, more would be better. But I'm just going to do a plant on the edge here just to show you how to pop a root out of the ground. Not that it's difficult, but there's some tips that you have to be aware of. So let's dig this plant up. All right, now at this point you'll have a large ball of soil, and depending on how wet it's been, that ball may be pretty heavy and muddy. The next thing you'll have to do is get a 5-gallon bucket full of water, dip this root ball in there and just dunk it in and out as many times as you have to get some of this mud off of there. A garden hose is handy too, to spray in here and pressure wash basically this root off, and then you'll be able to see the actual roots and look if there's damage there. So I have a couple of roots I've already dug here, and I'm just going to show you one of them here. You can see this is a pretty anemic little root mass, but what you would want to look for is on some of the interior roots is signs of feeding and scarring that would be due to insect feeding. Now there's nothing else that will cause scars and feeding tubes or feeding marks in a corn root. That would be all you would ever find in terms of the rootworm would be the only insect you would ever find causing that kind of damage. So this one here is fairly clean. Recording. All right, this root here was dug out of this field that had a lot of rootworm activity in it. So there's no doubt these roots were fed upon. But now that we're here in August, we can't really see what happened on this particular root, but what you do see is a lot of fine roots. This is newer adventitious root growth, and this often happens after root damage from rootworm feeding if you have moist conditions, which we did. In the last 3 weeks or so, we've had abundant rainfall here. And that's just like if you take a cup plant and you put it in water, it'll grow roots back. These corn roots can grow back as well. And you may not lose any yield at all, even after severe rootworm feeding, if there's abundant water afterwards. Where you can lose some in terms of harvest is the difficulty in picking up that down corn at with the combine equipment. But this here, all this root growth here makes it almost impossible to dig down and see where rootworm feeding has occurred. And that means that work has to be done right after the feeding. You can see here, I've isolated one root here. And you can see these grooves and some dark brown or necrotic tissue, and that's where the feeding has scarred over. And then look at all this new growth here on the end. Look at all of that. That's that plant responding to a lack of moisture and to a lack of root material and growing roots back when it can get moisture and where it can get to moisture. So this here was a response to rootworm feeding, and that plant can then not necessarily have yield loss, probably usually will from severe feeding. But the point here is that root dig has to be done in a timely manner. Mid-July to late July is the period when you would see the damage. After that, you'll get this regrowth and you'll just be having to dig in and do too much guesswork. All right, so as I mentioned at the top of this video, we have had more cases this year than in many years of a lot of rootworm feeding in conventional, unprotected corn. That's not too surprising, but what we want to focus on is what to do about it. Now, the first option, if you have a field like that, and this is an option that's available to most Indiana growers, but not all, is rotate to another crop like soybeans. So in a soybean field, assuming volunteer corn is controlled, you'll have a lot of rootworm eggs hatch. They'll look for a food source. They'll only find soybeans, and they'll all die. 100% of all the rootworms who don't find a corn plant in that field will die. That's the most effective technique. For some, that's not an option. For some, continuous corn is dictated by local markets and dairy and so forth. And in those cases, you do need to protect that corn. So if you still want to stay with conventional corn, there are tools. There are granular and liquid insecticides that work. They still work. They never have stopped working. There are several that you can find at our Purdue website, Purdue Corn Management, Corn Insect Management Recommendations. You'll find an up-to-date listing of those, both by active ingredient and by trade name. And those fell out of favor about 10 or 15 years ago, only because the transgenic hybrids are so much easier to handle and became so popular so quickly. But they never stopped working. The efficacy is still there. So if that's an option that you need to pursue, then those are still there for you. But the point is, going with conventional corn that is unprotected is a recipe for disaster. It may not be in year 1 or even in year 2, but the rootworms have never left. They're still out there, and they will find that unprotected corn, and we're seeing this year can cause quite a bit of damage in there. All right, I'm standing beside a soybean field that is adjacent to the field of conventional corn, unprotected, loaded with rootworm beetles. Now, many of you may have heard of the rotation-resistant variant or the soybean variant of the corn rootworm. It's common in most of Indiana, including where we are here. And what that means is all of these beetles that came out of this corn, they'll try and mate and lay eggs, and those females will not just lay eggs in corn. They've lost their fidelity, their faithfulness to only laying eggs in corn. So they'll dump their eggs all around us here. If we had a wheat crop, they'd even lay eggs in that. But there will be, you can be sure, there will be many eggs in this soybean field from corn rootworms. So what that means is if corn comes in here next year, which it will, if that corn isn't protected, you will have problems. If corn comes into this conventional corn next year, you'll have problems as well. So the point of what I'm getting at here is that if you have a field where you have a lot of rootworm beetles emerging for whatever reason, you need to be aware that the entire surrounding area is going to have a lot of rootworm pressure in terms of eggs next spring. So if you rotate after soybeans and you come in with corn, there will be eggs waiting for you. If, on the other hand, you come in with soybeans after corn, there will be eggs waiting for you, but it's something that you don't have to worry about. They can't feed on soybeans.
All right, so I believe I think I saw a Christian on there. So any questions for Christian? Sorry about I'm not sure what's going on with our video quality. It was bad on my end too, but I will email everyone on our list here the links when I get them uploaded on the internet, and we should have good quality there as well. But if Christian, I believe I saw you. Here is one question about rootworms that I have. So what kind of effect I know you talked about the rotation will take out the eggs, the next generation, because they won't have corn rootworm. What kind of effect, if we don't have good control of our volunteer corn and our soybeans, will that have on rootworm populations?
Okay. If we have volunteer corn and soybeans, we will be, we know that will host rootworms. Why is that important? The only significance of that is that that volunteer corn sometimes expresses lower rates of the Bt toxins. So it's like a weaker version of the parental, Smart Stacks hybrids and Acre Max hybrids and so on. And what that means is that any rootworms that feed on that volunteer corn are developing resistance. They're more able to survive on volunteer corn, which is weakly toxic to them, than on the corn that is planted in the field directly from seeds. So that's why one of the reasons we recommend to get rid of that volunteer corn early. If you have a clean soybean field with no volunteer corn in it, you will have 0 rootworms, 0 beetles coming out of it. Full stop. That's all there is to it. If you do have volunteer corn, you'll have beetles come out of it, but perhaps more importantly, those beetles will have been exposed to a low rate of the Bt toxins, and that's how we start to develop resistance. So that's the main reason that we advocate controlling volunteer corn early, along with all the other agronomic and weed management reasons that everybody knows.
Another question here. This is not necessarily about rootworms, but the effects of seed treatments. I know you've done some work on that in the past years. Can you give us an update on seed treatments and kind of the collateral effects and the economics of it, and is it worth it? Right.
Okay. Yeah, that's kind of a longer story, but to distill it down to what we've done recently, we've tried to work on what kind of pest management window you're purchasing when you purchase a seed treatment. So in other words, if you have seeds that are treated with Poncho or Cruiser or Escalade or whatever your neonicotinoid seed treatment is, how long are those plants toxic to pests that may show up? And what we found there is that window is a lot shorter than we thought. It's probably right around 2 weeks or so after the seed hits the ground. And after that, we don't see benefits. We don't see an opportunity for benefits because those insecticidal components are not in the plant anymore. They're in the soil, they're in the water, they move into the tile drains and so on. And then they have some collateral effects there that we could talk about in detail at another time. But the point is that as pest management tools, their efficacy window is quite short, shorter than we thought. So you need to be confident that you have those root feeding pests that are going to be present in that initial window after planting. Some research that's come out in the last year on large scale field trials, so several hundred grower trials, and this was done in Canada where they have more access to untreated seed, showed that about 5% of growers in that case had some measurable benefit from using treated seeds. So 95% did not. So it's not a reflection that these pesticides aren't toxic. We know they are. It's a reflection that you have a short window of activity and you have pests that are relatively infrequent. So you put those two things together, and you just don't have much opportunity to have a benefit in corn or in soybeans for that matter. So as we've looked at this more and more, we've found that because our pest populations are relatively low, our pest management window is relatively short, we don't have a lot of opportunity for those pesticides to pay for themselves, those seed treatments to pay off in corn or soybeans. That may not have been the case 15 years ago when they were introduced. I don't know. But certainly now our pest densities are very low. And that's what you might expect after this many years of using seed treatments on all the corn and the vast majority of soybeans. Every year you're putting this seed treatment out there, you're probably having some effect on many insect populations. And that we have perhaps historically low pest populations in part due to that trend. So that's a quick summary of where we are with that. And we encourage producers to explore options like using ordering untreated seed. You have to order it extremely early, like now, it seems. And even then, we've had a hard time getting it for research studies. You'd think it came out of the combine already treated with how hard it is to get untreated seed. But I would urge people to experiment with that. Leave a check strip or two and just see for yourself what's going on in terms of the possible yield benefits of using neonicotinoid-free seed. And when I say treated seed, I'm referring just to the insecticidal component. I'm not talking about the fungicide components. That's something that we haven't directly measured and we don't have expertise in. I'm just talking about clothianidin and thiamethoxam, which are the two big neonicotinoid components.
So 2 weeks. So that means that, for our early spring planting, the neonicotinoid seed treatment would be gone. If we do it early, it takes 2 weeks for seedling and emergence. Then
that's right. Yeah. About 2 weeks after it hits the ground, could be maybe 17 days on the outside, and it was about the same for soybeans. After that, there's no measurable difference between the seeds that were treated without neonicotinoid on them, between those plants, and the seeds that were treated with neonicotinoid on them. So the window is very small, and that's simply due to the fact that these seed treatments are very, very water soluble. So they go into the water, they follow the water, you get a rainfall, you have tile drainage, they go where the water goes. And it just leaves the area relatively quickly and doesn't stay there all year to sort of meter into the plant slowly as we would like to believe. It doesn't work that way. So the window is small, and it's due to the chemical properties of those particular molecules. They're very water soluble.
All right. I don't see any other questions coming in, but I'm sure you can reach out to Christian and he can give you some more information on any other topics here. So
Yes, thank you, Phil. Yeah, don't hesitate to reach out by phone or email. I'm easy to find. I'm the only person with that combination of names working at Purdue. So look me up and feel free to email me anytime or call. Thank you.
Yep. All right. Next up, we have Bill Johnson, and he's got a video here that they recorded looking at herbicide burn down treatment. So let me get that up for you guys.
Well, good afternoon. It's June 17th, 2020. And in light of some of the COVID-19 restrictions that are being placed on universities with regard to field days, many of us across the Midwest and the Mid-South area are doing these video recordings to try to get some of our information out to the end users. And so today what we're going to do is we're going to walk down through some plots that we've sprayed some burn down treatments on about 12 days ago. And basically what I want to do is kind of walk you through some of the things that we're seeing. And this would be kind of a central or west central Indiana type of environment that we've had this spring. And we want to talk about some of the efficacy that we're seeing on mare's tail on one side and giant ragweed on the other side. And then we'll give you some conclusions to what we're seeing here at the end. The first thing we'll do here is we'll set up our plot layout and application parameters. So the first series of treatments we're going to discuss were applied on June 5th. Our weather conditions were mid-80s as far as temperature, and we were coming off a little bit of a wet spell. And so our plants were well hydrated, so we hadn't experienced any drought stress yet. And our horseweed was anywhere from 4 to 12 inches in height. Sprayer was set up with 15 gallon per acre of carrier volume, and these were walked on with a backpack sprayer. So the way the plots are laid out, the sign is in the middle of the plot, and we have untreated running checks, which I'll point out as we move further down the line here to kind of show you what the weeds would look like in these running checks, and this would be an unsprayed area. Okay, what I'm going to do now is I'm going to walk you through 4 different treatments. So we've got an untreated check here, we've got a glyphosate product in the next one, and then a glyphosate plus 2,4-D and a glyphosate plus dicamba. So I'm standing now in the untreated plot. We are 12 days after the application of the treatments in the other plot. The horseweed ranged from 4 to 12 inches in height when it was sprayed. And now we have horseweed ranging anywhere from about 8 to probably 24 inches tall or so. So this is what an untreated check looks like. As I move in this direction here, I'm moving into the plot that was treated only with glyphosate. So obviously this is a glyphosate resistant population of horseweed. You can see a few dead plants in here, but for the most part, what you see are plants that were initially injured by glyphosate. They would show some yellowing in the tops, and then they started to regrow. So we have thinned the population a little bit, but I would say well over 90% of this population is glyphosate resistant. So this was a very common site in the state of Indiana dating back to 2001, 2002, 2003. And so most of the state then at that point made some pretty quick transitions to doing different things, whether that was adding post-emergence chlorimuron or chloranthalam to their glyphosate program, getting some 2,4-D in the burn down to try to get this mare's tail population to behave more like we want it to behave. So one of the most common things that was done back in that era, and one of the cheaper things, or probably the cheapest thing, was simply to get some 2,4-D in the burn down treatment. So again, we're 12 days out here. And when we compare the control with glyphosate alone versus glyphosate plus 2,4-D, it's definitely better. But what you can see here is even with adding an auxin herbicide, whether it's 2,4-D or whether it's dicamba, we are not getting very rapid control of these plants. So we've beat them up pretty effectively. You know, I think we've largely protected soybean yield if we can come back in here and finish these off with 2,4-D, dicamba, or Liberty. But to get an effective burn down, even when we have hot, sunny weather, throughout most of the state of Indiana now, we need to do something more than just adding 2,4-D or dicamba to our burn down treatment. And that's why we talk an awful lot during our summer meetings about doing fall applied herbicides to get those mare's tail controlled that emerged in the fall of the year. So that way we don't have a population like this that we have to deal with in the spring. So as I move over to this plot that had Roundup plus dicamba, again, we see a very similar scenario here with Roundup dicamba versus Roundup 2,4-D. We're 12 days out. The plants aren't dead. They probably haven't grown all that much, but anytime I still see green on a plant 12 to 14 days out, I'm concerned that I'm going to have to come back in here and retreat. Okay, we're moving down the line here into some of our other treatments, and I'm standing in the running check or an unsprayed area. And we've got two different treatments that we're going to discuss here. So the treatment on my left would be Roundup plus Sharpen. The treatment on my right would be Roundup plus Sharpen plus 2,4-D, right? Yeah. Okay. So one of the things that became really obvious, as we pointed out in the discussion of the previous plots, was that adding 2,4-D or dicamba to glyphosate is better than glyphosate alone, but probably not getting us completely to where we want to be, where we want weeds that are, for the most part, dead at 12 to 14 days after treatment. So BASF developed the Safe Flufinicil product. I was part of that testing process around 15 years ago, and about 10 years or so ago, that product came onto the market, and it really helped out in terms of being able to control mare's tail, giant ragweed, and some of the other weeds that are typically present early in the growing season. So what you can see here with this Roundup Sharpen treatment is we definitely have very good efficacy on the horseweed. We still have a few plants that have some green tops in them, and those plants will survive. They will go on and complete their life cycle if they're not treated again. But we've done a pretty good job of getting these things beat back and giving our post-emerge herbicide a better chance of working on a weed that's showing a little bit more injury symptoms. When we have the 2,4-D in with the Sharpen, what you can see here is better control. We still have some plants that have some green stems on them. We have a few regrowing in the front of the plot, which that could be a matter of getting the boom charged. But what you see as you scan the entire plot is you just don't see the plants that have the green tops in them. So having both the Sharpen and the 2,4-D with the glyphosate has been the best treatment that we've looked at so far today. All right, now I'm standing in between our two gramoxone-based treatments. So we have gramoxone and a metribuzin-based product on my left. We have gramoxone, metribuzin, and 2,4-D on my right. And what you see here is, again, a very quick efficacy with these gramoxone-based treatments. With the gramoxone Syncor that doesn't have the 2,4-D in it, much like we saw with the Sharpen treatment that didn't have 2,4-D in it, you do see a lot more plants that are green in the top and that will go on and complete their life cycle. They're set back quite a bit. They can be finished off with a post-emerge treatment of the right mode of action. But if we simply add 2,4-D into our gramoxone-based treatments, the efficacy is a little bit higher here. Not quite as good as what we're looking at with the glyphosate, Safe Flufinicil, and 2,4-D, but nonetheless, we did get a better kill where we had two alternative modes of action in this mixture as compared to the one alternative mode of action. Okay, and the last thing I want to talk about here with our mare's tail plots are these Liberty-based treatments. Now, typically we don't think of Liberty as a good burn down herbicide because Liberty as a herbicide works much better under sunny, hot conditions with high humidity. So typically if we're doing burn down treatments in April, we don't have that kind of weather in the eastern corn belt. Now, given the fact that we did these burn down treatments in early June, we had 80 degree and sunny weather, and we also had some well-watered plants. Liberty was really active, and that's kind of an optimal situation to use Liberty. So on the left here, we have Liberty plus. On the left here, we have Liberty by itself. On the right here, we have Liberty with 2,4-D, okay? So again, as you look across these plots, the efficacy was very fast. It's been fairly complete with both Liberty and the Liberty 2,4-D. And so for those of us that didn't get our beans planted in early May, if we're into this June planting time frame because of wet weather, or perhaps we're double cropping, this would be a good situation here to use a Liberty-based herbicide for a burn down program. So to wrap up our discussion of mare's tail burn downs with early June applied burn down treatments, obviously it's a glyphosate resistant population. Adding 2,4-D and dicamba to glyphosate was definitely better than glyphosate alone, but we really needed two or more active modes of action in that mixture to get effective burn down control. So treatments that had glyphosate plus Sharpen plus 2,4-D, Gramoxone, Sencor plus 2,4-D, or the Liberty-based programs were the programs that gave us the most thorough control of mare's tail. And again, what we're really trying to do is we're trying to get 98 to 99% control. We want to stunt these plants as much as possible, and we want to be able to have our give our post-emerge herbicide an opportunity to work. So that's kind of the summary of mare's tail burn down, and we'll go on and talk about giant ragweed next. One of the things that we frequently encounter in our no-till systems in the state of Indiana is not only do we have things like mare's tail, chickweed, henbit, purple dead nettle, crestleaf groundsel, and some of the winter annual grasses to deal with, but it's not uncommon to have some of our early emerging summer annual weeds like giant ragweed, lamb's quarter, and foxtail to be emerged at the time that we're doing these burn down treatments. And so one of the things I think particularly that's become more important is the ability of this burn down herbicide to work on these early emerging summer annual weeds. So typically with grasses like foxtail or even fall panicum that might come up early, glyphosate works really well on those grasses. We haven't had any issues. Where we've run into challenges is getting good activity on lamb's quarter and giant ragweed in the spring under some cool, cloudy weather conditions. Now, the good news is that with the herbicides that we use in a burn down scenario, both lamb's quarter and giant ragweed are fairly easy to control. So efficacy is almost always fairly complete and fairly high when we have things like 2,4-D, dicamba, or saflufenicil, the Sharpen product, in the tank. So we didn't see quite the treatment separation out here with those particular herbicides, but the key thing to keep in mind is whenever we have cool, cloudy weather, we just need to be careful with lamb's quarter because lamb's quarter becomes really tolerant to glyphosate treatments when we have cool, cloudy weather. Giant ragweed, on the other hand, giant ragweed is so sensitive to dicamba and 2,4-D that we really can have effective control of those weeds just by having at least 8 ounces. We'd like to see 16 or more, but at least 8 ounces of one of those products in the tank for a burn down situation. So we're not going to walk you through all these giant ragweed plots. We just basically wanted to give you a summary there that, again, for those weeds, dicamba or 2,4-D or Sharpen is going to be a very effective program. But if you have mare's tail, you need to make sure you have at least 2 active sites of action in there to pick up the mare's tail. Because it's probably not likely that you have many no-till fields that have giant ragweed and that don't have mare's tail, because mare's tail has become so prevalent over the last 15 to 20 years.
Hello, my name is Jesse Harmon. I'm a second-year PhD student with Bill Johnson in the Weed Science Group at Purdue. We're standing here at Davis Purdue Ag Center, where I'm overseeing 13 company field trials. These trials were planted in late May and received a half inch of rain immediately after pre-emergence herbicide application. Throughout the month of June, though, we received relatively little rain, which slightly stressed the crops, but also led to exceptionally high pre-emergence herbicide efficacy.
Good morning. I'm Bill Johnson, Extension Weed Scientist at Purdue University. It's July 1st, 2020, and this morning we're here at the Davis Purdue Agricultural Center in Eastern Indiana, and we're shooting some videos of our weed control plots. So in this particular trial right here, we're looking at a lot of the commercially available atrazine premixes as a pre-emerge treatment alone and as a split treatment where we put on a portion of it pre-emerge and a portion of it post-emerge. So on my right-hand side, we have Resicor, full labeled rate of Resicor, and on the left-hand side, we have Harness Max, okay? So these trials were initiated in late May, around May 26th. The pre-emerge treatments were put on May 26th, so it's July 1st, or about 5 weeks after the application date. Our weather conditions were, we had a half inch of rain almost immediately on these pre-emerge treatments. Then it was dry, very dry for about 3 weeks. And then more recently, we've had some rainfall events. So what we have in the front on each side of me is a full labeled rate of Resicor and Harness Max. And in the plots directly behind me, these plots are 30 feet long. In the plots directly behind me, we have treatments of the same herbicides where some of it was put on pre-emerge, and then a post-emerge treatment of the same herbicide was put on around June 20th. And we're about 10 days or so after that post-emerge treatment. So what this very clearly shows is that pre-emerge herbicides are very valuable to use at planting. And what we see here, where we have the full labeled rate pre-emerge, is we have held the weeds back easily for 5 weeks, but we're starting to have some breaks now, okay? So this particular corn is at the V7 stage. It's about knee high on me. So we're kind of getting into a situation where we have limited things that we can do from a post-emerge standpoint because the corn is at an advanced growth stage. It's beyond the V6, which really starts to limit what we can do. Now, if we take a look at the plots directly behind these, where we had some of the pre-emerge herbicide put on at planting and then some of it about 10 days or so ago, those plots are completely weed-free at this stage. And so it does show the advantage of breaking up that residual, putting some of it on pre-emerge, some of it on post-emerge, and that helps to buy you a little bit of insurance against situations where we run into dry spells or extremely wet spells and our pre-emerge herbicides start to break early. Okay,
Right.
Phil, do I have control here?
Yep. If you want to share your screen or whatever. Yeah. So any questions for Bill, you can enter them in the chat. It doesn't have to be about burn down, but any weed questions whatsoever.
Yep. Yeah, go ahead and fire them. Phil, do you have any in your that have been emailed to you directly?
I've got a couple questions here. So I know that this spring we had that court case talking about dicamba. So is the future of dicamba in soybeans, at least, is that done with? Because I know 3 of the 4 products labeled for soybeans were taken off the market then. So
Right. Yeah. No, my read on it is, right now there's a heck of a seed supply that's going to be available, and I know the companies have submitted registration packages for new formulations to EPA to be considered. So my read on the whole situation is that EPA is very likely to approve some formulations of dicamba for use in soybeans for next year. And I know that's what the companies that carry the seed and the product are relaying to growers as well. So as of right now, I would plan on the ability to use a dicamba-based soybean system next year. All right, any other questions? I'll check the chat box here.
all right, so here's one. Are there any control options for tall mare's tail in soybeans now? I'm guessing right now mare's tail are poking above the soybean canopy. Or other late season option for other weeds and grasses. I guess.
Yeah, you bet. If the kids aren't back in school yet, send them out there with a hoe. That's really the only. So if you think about what we have labeled for use herbicide wise in soybeans right now, there's nothing labeled for use in soybeans that have more than 30% grain moisture and we're past the flower stage. So the only thing that you could use legally would be something in a rope wick type of applicator, and then you have to weigh the benefit or the detriment of driving over a lot of soybeans as far as the weed control benefit. So the non-smart aleck answer to the question is that there isn't anything that's labeled other than something you would put on with a rope wick applicator. And in order to make a rope wick applicator work on something like that doesn't have a lot of leaf area, you need to hit it from two directions, and so you're going to be running over the beans twice with whatever you're using through that rope wick applicator. But another common question I'm getting along that same lines is, what can I do to water hemp to reduce seed production? And again, if most of the water hemp is glyphosate, ALS, and PPO resistant, then you don't have labeled options really that can be used other than dicamba and 2,4-D. And again, we've got the cutoff to deal with of June 20th with dicamba. With 2,4-D, we're well past the R2 growth stage for its cutoff, and so there's nothing legally that can be done. Now, as we get later in the growing season, there are some harvest aid treatments that can be used in soybeans, but usually those are done after the beans drop the leaves, and then again after your grain moisture is 30% or less.
So we have another question. I think is there an issue with the early cutoff date with soybeans with dicamba products? And I guess now they have to spray that early, and now they're having Palmer going to seed. So any solutions with that?
Well, for this year, no. I mean, and again, about all you can do to prevent seed production at this time of the year is either hand weeding or some kind of a rope wick. Now, I would not put dicamba or 2,4-D in a rope wick and drive that unit across a soybean field that doesn't have that trait. The dicamba would be illegal anyway. If you put 2,4-D in a rope wick, I would not drive that across the field that doesn't have the 2,4-D resistant trait in it for fear of damaging the beans, for getting exposure to the beans, number one. And number two, the legality of it is just not there as well. So there's nothing legally they can do. As we get into this pre-harvest type of a treatment, then you have to ask yourself, okay, is the money that I'm going to spend on the pre-harvest treatment worth the benefit that I'm going to get from minimizing seed production? So you would want to go out into the field, see if those Palmer amaranth plants have already produced seed, and by that time many of them will have black or brown seeds on them. If they have black or brown seeds on them, then the seed is mature, and you're really not doing yourself a lot of good from that standpoint.
So then,
go ahead. I don't know if
I think. Well, what about for next year? So assuming you can use the dicamba product again. And another question is related to that. So next year, you said you'd have dicamba. You foresee it's going to be on the market, a different formulation. In Indiana, are we still looking at that same June 20th cutoff date?
Yeah. So again, the state chemist makes that decision, but my read is that they are they're fairly pleased with the purpose of the cutoff date and the result that it's had. So the purpose of the cutoff date is to reduce the number of off-site incident reports and reduce the number of the complaints that they have to process, and it's had that effect. So I really don't see them making a dramatic change in that cutoff date, because it did have the desired effect at reducing the cases and the case load that they have to deal with as far as off-target movement. As far as how to plan a weed control program, one of the things that I've been really frustrated with over the last couple of years is we're going down the same pathway that we went with Roundup Ready 25 years ago, and that we're throwing the residual herbicides out the window, and we're putting so much reliance on that post-emerge herbicide to do all of our weed control. So, we've been through this, more than once. We went through it with ALS inhibitors in the late 80s and early 90s. We went through it again with the with the glyphosate-based program starting in the mid-1990s, where we become so reliant on the post-emerge herbicide that we spray it multiple times, and that just drives that resistance curve. And so the same thing is going to happen with dicamba and 2,4-D. I mean, we're already screening populations of water hemp for dicamba resistance. So it's only a matter of time until we have that first one that we label. And, congratulations to the county that has it. And then, from there, it will develop in other counties as well. So what we really need to do is, again, get back to basics. The residual herbicides have always been and still are the backbone of our weed control programs in corn and beans. And unfortunately, we migrate, regardless of the technology, we want to migrate to this system where we become so reliant on the post-emerge herbicides. So for palmer and water hemp in particular, residual herbicides, full rates of residual herbicides, not the planned failure setup rates, but full rates of residual herbicides, and then timely post-emerge treatments. And that post-emerge treatment needs to have a group 15 with it as well to help suppress that late season emergence.
So is there any confirmed dicamba resistance in Indiana yet?
None that are confirmed, but we have some populations that it takes higher rates to kill in our greenhouse studies. And so we just need to, we'll do some more work with those. And it'll be like the early days of glyphosate resistant mare's tail. What'll happen is it'll take a herbicide rate that's right at the limit of the 1x rate, sprayed to a small plant, applied with your mouth held right in order to make it die. And so that's what'll happen first. We'll have these plants that show low level resistance. And then what happens over time as this resistance curve evolves is eventually you have small plants that you don't touch with a 1x rate, and those will be mixed in there with dead plants. And then eventually you'll be able to spray entire fields and kill very few plants. And then we'll react and say, man, we need to do something different. If I've kind of watched this resistance curve evolve a couple of times. So none that are confirmed yet, but some that are just a lot tougher to kill. And in a lot of cases, they're in situations where dicamba was used in corn for many years. And then in soybeans, we've gotten into this respray program. And so when the resprays don't kill it, that's when it kind of comes to our attention. And we've gone out and collected a few plant samples both last summer and this summer, and we're working on those in the greenhouse right now.
Okay, so here's a question. I want your thoughts on the Perpetuo herbicide by Valent.
Yeah, I got to remember the active ingredients. It's a pre-mix of, I've got to look it up now. It's a Zidua. It's a pre-mix of active ingredients we already have. So our opinion is going to be whatever our opinions were of those active ingredients, which you can get out of the weed control guide. In the weed control guide, there are weed response tables in the front section of each crop, and we give you a relative efficacy number for both single products and the commonly used pre-mixed products. So, again, I'd have to remind myself on the ingredients there, but I think it's just a matter of going in there and looking up those active ingredients and figuring out what weeds they work well on and what weeds they need some help with.
Okay. So another comment saying if we have this dicamba cutoff date of June 20th, which likely happens, and then we've got our water hemp and palmer that keeps emerging even with in-crop residuals. Is this a good technology for Indiana then in that situation?
Well, it's planted on 60% of the acres this year, so somebody likes it. So here again, here's where you start. You think through this whole process, and for those fields that require resprays, what was the entire weed control program for that respray? Was it a situation where clean tillage, beans were planted, and then you did all of your weed control with post-emerge treatments? And if you have to respray that situation in Indiana, I'm like, that happens every year, right? If we don't use a residual herbicide, well over 50% of our soybean acres are going to require to be sprayed post-emergence twice because we have an environment with plenty of rainfall, and we have weeds like water hemp, giant ragweed, crabgrass, and stuff like that, morning glories, that have relatively long emergence patterns. And so it's very unlikely that a single trip over the field is going to provide complete weed control. So that's where I would come back to that is, I'm going to answer the question. The technology is fine. It's how the technology is used that kind of determines its value. Now, the other thing to keep in mind is that we do have the ability in the E3 beans, and next year, if Bayer gets the approvals for XtendFlex, in both the XtendFlex and the E3 technologies, will have the ability to spray Liberty. Liberty does not have a calendar cutoff date. It has a calendar cutoff soybean growth stage. And so if a person is bound and determined to focus just on post-emerge weed control, then you're going to be in a situation where you spray your dicamba early because you have a cutoff date, and you have the ability to use Liberty late. You have the ability to use Roundup both early and late. And so if you have a situation where you have some glyphosate resistant weeds, and then your Roundup kind of becomes your primary grass herbicide. But again, it's all about how the technology is used. It doesn't mean that it's bad technology. It just means that the use pattern it needs some tweaking. Okay. Any other question?
Well, I guess so. They're saying they're seeing lots, even with the residuals, they're seeing lots of water hemp out there in their area.
Yeah, well, I mean, if you're on a muck soil, that makes sense. It's hard to make residual herbicides work as well on muck soils as they do on mineral soils. I'd ask the question, what rates did you use? What were the active ingredients, and what were your rainfall patterns like? I think if in Indiana this year, if you're in an area that has drought-prone soils, and you think about that dry spell that we had in June, we had a dry spell in June that was, borderline drought, and your soybeans are short and they didn't canopy. Those were environments there where it's not uncommon to see water hemp leaking through there. Throughout a lot of the state, it's not uncommon to see water hemp leaking through the crop canopy. And some of it driven by the fact that, we had a really dry June and we didn't get quick canopy development because the beans were water stressed. But I also know that residual herbicide use went way down this year, driven by a lot of different factors. Number one, the promise that dicamba was the next Roundup, and number two, low soybean commodity prices, and folks were looking to cut costs. So there's a lot of reasons for it. I mean, it doesn't really mean that the technology is bad, but in situations where the crop canopy is hugely important. Basically what we try to do with herbicides is we try to give that crop a 6-week head start. And then once we get canopy development, we're pretty reliant on that crop canopy to give us weed control throughout 2/3 of the growing season. So basically you're looking at the first third is herbicide based, and your last 2/3 are based on the crop canopy. And so, anything we can do to supplement our herbicides, whether it's using the right rate, whether it's picking the right herbicide for the weed population, or figuring out ways to incorporate non-chemical means, whether that's a high biomass cover crop can be very beneficial in soybean on some weeds. We also know that people are now, getting back into wider rows and using some row cultivation as well. So, the thing to look at is we no longer have a herbicide market like it was in the 80s and 90s, where the promise of a new active ingredient always kind of gave us some hope that we could continue down this path of chemical-only weed control. There's no new active ingredients. There's no new sites of action that are coming to market anytime soon. There's some new active ingredients, but their sites of action we're already using. So there's a pretty good probability that, those things are going to have kind of a short life cycle. So we really need to think about, some of the old tried and true methods of weed control, and how can we incorporate some of these non-chemical things with our herbicides to extend the life of our herbicides.
Guess one more thing along those lines is more of a long future thing. Recently, you know, with all those glyphosate lawsuits and everything, what kind of future, you mentioned some of that, non-chemical options for weed control do you see coming down? Because, you know, if our regulatory environment changes where we might be losing some of this technology, not just to resistance, but to regulatory things. So
yeah.
Any thoughts on that?
Yeah, no, that's a good question. I mean, that kind of ties into my last statement there. You know, I think the fact that we're in the middle part of the country, you know, we're going to see things like, you know, the dicamba cutoff dates, times, temperatures, whatever you want to call it. I don't think those things are going to go away. I don't have the vision, though, that we're going to be banning glyphosate or banning glufosinate or things like that. I don't see that happening anytime in the near future like you would if you were out on the West Coast, for example. But in terms of, you know, what we can do from a non-chemical standpoint, you know, for me right now, the low-hanging fruit is, you know, tillage. You know, whether it's pre-plant tillage or row crop cultivation, that's low-hanging fruit. You know, and again, we don't want to go back to tearing up soil if we don't have to, but there are some high residue cultivators. We bought one for our research program, but there are high residue cultivators that can be used in those systems. Number two, understanding how you can make a cover crop help you. So again, what we've learned with cover crops is that high biomass cover crops in soybeans can be pretty reliable on a couple of weeds. But it does require additional management. It's not a matter of throwing seed out there, planting beans, and then, you know, hoping for the best. I mean, the cover crop has to be terminated at the right time. Your planting equipment has to work to get seed placement and seed emergence. So I see those two as things that there's a lot of people that can make cover crops and tillage work. Things like electrocution, you know, I think that's interesting, but when you look at the timing of electrocution, and there's a lot of videos that have been posted recently on electrocution, the timing of electrocution right now is late in the year to prevent seed production. By that time, the competitive effect is already done. And then it's kind of like rope wicking. You're still driving a piece of equipment across cropland, and you're going to do some damage with that. I think if electrocution can be used earlier in the year, and someone can figure out a way to run the probes down in between the rows, so we can electrocute smaller weeds. I think that one is going to become more of an early season tactic that we can use. Right now, that is a late season. So early season tillage, you know, whether it's pre-plant or row cultivation, and then figuring out how to make a cover crop work are probably the two things that we can do in the short term.
All right, thanks, Bill. And I guess if you have any other further questions, just reach out to Bill and he'll answer them for you. And that concludes our program for our Pinney Purdue Field Day. One other thing, we didn't get our, we were looking into the technology. I don't think it's quite there for a virtual pork chop lunch. So again, thank you everyone for logging in today, and hope you got some good information, and we hope to see you next year in person for our Pinney Purdue Field Day there.